Now, of course, this doesn't answer the problem of the golf ball, because it's like, you know, it's as though we said the guy either is going to shoot 33 yards or he's going to shoot 66 yards, and then asking what's the chance he's going to get to 100 yards. It's a related problem, but it's not the same problem. It's a related problem. But now we can make a closer analogy. Instead of just taking our continuous distribution and chopping it into 3 finite lumps, we're going to take it and chop it up a little finer. We're going to say it's a 3-sided dice, which has a 1, a 2, a 3 on it, and we're going to ask how many times you got to shake the dice before you add up to 4. No one's going to get there in the first shake. They're going to be either here, here, or here. Then on the second shake, some of them are going to get there. Now let's see how it looks. It's just a slightly more complicated than the Pascal's triangle that we've already generated. So I'm going to take the Pascal's triangle off the board, because the board is a little small, and say, here we go. 1, 2, 3, 4, 5, 6. And after the first shake of the dice, there's a guy on 1, or a guy on 2, or a guy on 3. But no one got up to 4. After the second shake of the dice, this guy could have got here. There's 2 ways you could have got to the 3rd square, because you could have got there from here or from here. There's 3 ways you could have got to the 4th square, because either of these 3 guys could have made it to the 4th square. It's just like when we had those Monopoly dice that peaked up. They went from 2 to 7 and then down to 12 again in a continuous distribution. Well, they go up and now they start coming down again, because there's only 2 guys that could have made it to the 5th square. Only these 2 could have made it, and only 1 guy could make it to the 6th square. So it looks like, as far as getting up to the 4th square, 6 guys out of 9 made it on the second shake. 6 out of 9 have made it on the second shake. Now, let's go to the next shake of the dice. There's only one way you could still be on the 3rd square. Everyone else is going to make it, except for this one guy that's been unlucky that he's rolled a 1 3 times. There's, how many ways could you have got to the 4th square? Well, 2 of these guys could have made it, and this guy could have made it, so there's 3 ways you could be on this square. As far as the 5th square, there's 3 plus 2 plus 1, 6 ways you could have got here. There is, in fact, 8 ways you could be on the 6th square, because 2, 3, or 2 could have all got here. And then the distribution goes down again. 6, 3, 1. Notice that the smoothness of the curve, 1, 3, 6, 8, 6, 3, 1, rising steeply, peaking smoothly, and going down again, becoming like a Gaussian curve. And on the next shake of the dice, everyone's made it, so we don't care. So 6/9 of the guys made it on the second shake. On the 3rd shake, out of 27 possibilities, 26 have made it. We have 26 out of 27 who have made it on the 3rd shake, and 27 guys, they all make it. 27 out of 27 make it by the 4th shake. So cumulatively speaking, now I'll change this to common denominator. I'll make this 18 out of 27. We got 18 out of 27 times 2 who made it on 2 shakes. From 18 to 26 is 8. So 8 guys made it on the 3rd shake. 8 times 3, and 1 guy made it on the 4th. So we got 36 plus 24 plus 4 equals 64 out of 27. This is your average number of shakes, 64 27ths, when you got 3-sided dice. Now let's remember, when we had a 2-sided dice, our average was 9/4. When we had a 3-sided dice, the average was 64 27ths. 9/4, notice, is 3 over 2 squared. 64 27ths is 4 over 3 cubed. Now, does anyone have the slightest doubt that if we took a 4-sided dice and rolled to see how far you take to get to 5, that the average throw would be 5
over 4 to the 4.
To the 4.
Amazing. Impossible.
Unbelievable. And if we had a 100-sided dice, so that it was very, very much like our original golfing problem, that the probability of number of shots would be 101 out of 100 raised to the 100. And in the limiting case, as this fraction becomes smaller and smaller, the exponent becomes large, this thing tends towards a limiting value, famous number in mathematics, 2.71828 equals E, Euler's constant. Incredible number. What are you going to say? We don't have time for song, do we? Don't have time for problem? Okay.
Problem or
Problem. Okay. Problem. This is a tricky one. And I'll just write it in a hurry. And I want you to tell me the volume of the region defined in space in the cube, the unit cube with its center at the origin and its vertexes at points like 1, 1, 1. So this is here's your points 0, 0, 1, etc. So it's a unit cube, and here's your origin. Find the volume of the area defined by x is less than y is less than z. Funny problem. The volume of the region defined by the relation x is less than y is less than z. We'll solve that next week. What do we got now?
I don't know. Pull up a chair, Mark.